Hello everyone, welcome to this video. This video is on the differences between microprocessor and microcontroller, RISC and CISC, and Harvard and Von-Neumann architectures. Generally these questions we see in the exams for 5 to 6 marks. First let us look into the microprocessor versus microcontroller. See this diagram indicating a microprocessor and this diagram indicating a microcontroller. Easily you can make out the difference here is that the microprocessor consisting of a CPU, means this complete thing what I have represented in a block diagram is a CPU, means microprocessor will only be consisting of CPU. Within the CPU, as we know, we have arithmetic logical unit supporting registers and some controlling unit will be there. But in the microcontroller, you can see CPU is a part of microcontroller, and also we will be having RAM inside, means within the microcontroller itself, ROM within the microcontroller itself. There are some counters and timers and IO ports. So these are the things present in the microcontroller with the CPU. But microprocessor will be consisting of only CPU. These RAM, ROM, counters and all we need to be connected externally to the microprocessor. This is the main difference. You can see here also in the difference section, microprocessor consists of a CPU to perform arithmetic and logical operations. For example, it is 8086 microprocessor. In microcontroller, you can see it is an integrated chip. It is a highly integrated chip consisting of CPU, RAM, on-chip ROM, RF flash memory, IO ports and interrupts control unit and also timer, counter, etc. and etc. So microcontroller is a complete system or complete microcomputer we can call. But microprocessor need external devices or external components called counters, timers, ROM, RAM, everything. So this microprocessor mainly used in personal computers. In your personal computers and laptops, you can see these microprocessors that require high capacity. So we are going to have external hard disk with the microprocessor. We will be having extra RAM with the microprocessor. So these are going to operate with microprocessor in a system or computer. So these are used in personal computers. These microcontrollers are used in small embedded system devices. These embedded systems are very small compared to the personal computers, and these contain microcontroller because whatever there in the microcontroller itself is sufficient to make a embedded system. That's why microcontroller is a device which will be act as microcomputer, I said. And microprocessor is complex and expensive with large number of instruction to process, and microcontroller is simple and inexpensive, not so expensive, with less number of instruction to process. And microprocessor is a dependent unit. Why? Because external RAM is required, external ROM is required, timer, counter, clock generator, everything is required here. That's why we call it as a dependent unit. This is self-contained unit. All the components present in the architecture of the microcontroller itself on chip. Within the chip itself, all are there. This microprocessor consumes more power. Microcontroller consumes less power. Since these are used in embedded system, so power need to be used effectively, so it consumes less power. And here in the microprocessor there are limited power saving options. Here there are lot of power saving options are embedded inside. And this architecture microprocessor will be based on Von-Neumann architecture. Let us see in the next difference what is Von-Neumann and what is Harvard. So remember, microprocessor will be dependent on Von-Neumann architecture and microcontroller will be dependent on or based on Harvard architecture. And it uses external bus to interface RAM, ROM, as I said, other peripherals. Here it requires an external bus also to connect these. In microcontroller, it uses internal connecting bus or controlling bus itself. So these are few differences, 78 differences, very important differences you need to remember. This will be a very important question asked many times. Then we'll see what is RISC and CISC processors. RISC, R-I-S-C means, if you know the expansion of these two, we can make out the differences easily. RISC means it is reduced instruction set computing or computer. Means these kind of processors, means the processor, if it is under the RISC, it consists of reduced instructions with reduced instruction set. So the first difference is that it is consisting of reduced number of instructions or reduced instruction set computer it is. CISC is complex instruction set computer. Here the instruction set is very complex, very huge we can say. Here the reduced number of instruction set means the instruction set is less number of instructions are there to code. Here more number of instructions are there to code, and that is the second difference you can make out easily. And using these less number of instructions, because of the less number of instructions we need to use repeatedly, the large code size will be for the coding. Here complex instruction set computer code size will be small. Why? Because there are multiple instructions we can use and we can code it. So code becomes smaller in CISC, code becomes larger in RISC. It do not require external memory for calculations, it requires external memory for calculations. Here the execution time is very less. Why? Because the complexity of the instruction is itself less. Here the execution time is very high because the complex instructions are there. It is a software centric design and it is a hardware centric design. CISC complex instruction set is a hardware centric, RISC is a software centric. It requires more RAM, it requires minimum amount of RAM. And simple decoding of instructions in RISC. Why? Because the instruction set is simple here, so decoding is also simple. Here the instruction set is complex, so complex decoding also required. Processors are highly pipelined here, or not so highly pipelined, or less pipelined we can say. Here it uses multiple registers, it uses a single register. Here compound addressing mode is present, here the addressing mode is limited. And RISC architecture can be used in high-end applications like telecommunications, image processing, video processing units. RISC processors will be used. And CISC architecture can be used in low-end applications like home automation, security systems, consumer goods, like embedded system things, complex instruction set will be used. And it has a fixed instruction format of 32 bits. Here it will be vary from 16 to the 64 bit. Like here the examples are ARM, PIC microcontroller, power architecture alpha, ARC, AVR, Spark. These are few of the examples of the processor and controllers which designed using RISC processor, RISC type. Here VAX, Motorola 68000 family and system 360, AMD and Intel x86 CPUs. These are dependent on the CISC architecture. So this is about RISC and CISC. As I said, reduced instruction, here it is complex instruction, that need to be remembered. Then let us see Harvard versus Von-Neumann architecture. So first look at the diagram of Von-Neumann architecture and the Harvard architecture. What difference we can make out easily is that Von-Neumann architecture will be having a common bus, means common lane or common path between the three devices. If CPU want to communicate with the IO device, CPU should go to common bus. Through the common bus, it should access IO device. At that time, this line is busy, so memory and data cannot be accessed by the CPU. So then IO device communication is over, then CPU has to come through the common bus and communicate with the memory, data and code. So this is Von-Neumann architecture. It uses common data bus. Here in the Harvard architecture, you can see this is CPU. CPU is connected separately with the program memory, separately with the data memory. So data memory and program memory can be parallelly accessed in Harvard architecture. Now let us see the differences. Von-Neumann architecture this side, Harvard architecture this side. It is an ancient computer architecture based on the stored program computer concept. This Von-Neumann architecture is old or ancient. This will be the new one, or Harvard architecture is new. This is modern computer architecture. And CPU is connected to the data memory and the program memory by a single memory. Here, ROM and RAM by a single memory. Here CPU is connected to data memory, that is RAM, and program memory, that is ROM, separately. and CPU cannot access the instructions and data at the same time. As I said, data and memory, data and instructions cannot be accessed at a time in Von-Neumann. Here, the access of instructions and data can be done by the CPU in the same time. Same physical memory address is used for instructions and data. Here, it is separate physical memory address, and the address is used for instruction and data. Here there is a common bus between data and instruction transfer. Here is a separate bus for data and instruction transfer. This is the only difference between the Harvard and Von Neumann architecture. Here there is a common bus, there is a separate bus. The speed of execution is obviously slower here because of the common bus. It has to wait for the completion of instruction fetch, then the data fetch is going to happen. That's why it is slower. Here it is faster because it is not compatible of fetching the instruction data at the same time. Here at the same time we can fetch the data and instructions. It is cheaper in cost, it is costly, and it requires less hardware but low performance. It requires more hardware and high performance. And this Von Neumann architecture used in personal computers and small computers. This Harvard architecture used in microcontrollers and digital signal processing. So I said while explaining the microcontroller, Harvard architecture is used. So this is the differences between Von Neumann architecture and Harvard architecture. We need to remember is that Von Neumann architecture is the old one. It uses single bus or the common bus for instruction and data. Harvard architecture is the new one, or the recent one we can say, where it uses separate fetching or separate bus for the data as well as instruction. So Harvard architecture is preferred more. These are the differences between microprocessor and microcontroller, RISC and CISC, and Von Neumann and Harvard architecture. Thank you.